Hello everyone, myself Saujanya and my friend Abhishek. We are currently pursuing our final year engineering in Bangalore Institute of Technology. We are here to present our embedded systems internship project on washing machine simulator provided by Emertxe Technologies conducted in the month March. I would like to explain introduction part of our internship and project execution part will be explained by my friend Abhishek. Washing machine has become an integral part of human beings in order to perform their daily chores of washing clothes. Over the course of time, with the advancement in technologies, different types of washing machines have come up in the advancement in embedded systems. Through this, we try to throw light over the systems of the washing machine and its working with few additional features. The key takeaways in the internship. In our internship, we have learned about basics of embedded C programming and microcontroller PIC16F8778. Embedded C programming basics includes keywords, data types, conditional statements, operators, structures, arrays, functions, pointers, extern, macros, and header files. Basics of microcontroller includes input-output pin configuration, timers, and interrupts. We have also studied some of the functionalities of the hardware components required for our project. It includes switching circuits, CLCD display, fan, and buzzer. Basics of C language. Let's know what's the basics of C language required. What is C language? It's a general purpose procedural computer programming language supporting structured programming, lexical variable scope, and recursion with a static type system. It is a general purpose language even though it is applied and used effectively in various specific domains. Efficiency and portability are the important considerations. Where C is used, C language has numerous applications. Some of them are system software development, embedded software development, OS kernel development, firmware, middleware and driver development, file system development, and many more. Let us know about the elements of C language. The first one is data types. Data types is used for declaring the type of a variable. It determines the type and size of data associated with variables. Data type is a collection of data having fixed values, meaning as well as its characteristics. It is classified into primary data types, user-defined data types, and derived data types. Primary data types are simplest forms of data that a programming language can recognize and operate upon directly. It includes integer data type, floating data type, character data type, and a Boolean data type. User-defined data types are defined by the user rather than being built into the programming language. It includes enumerations and typedef. Derived data types are the data types derived from primary data or other derived data types. It includes pointers, arrays, structures, and unions. Let us know about the another element of C, that is keyword. Keywords in C are reserved words that have predefined meanings and are part of the C language syntax. These keywords cannot be used as identifiers or variable names as they have specific function. There are 32 keywords. Some of them are in double, if else, etc. Let us know about the conditional statements in C. Conditional statements in C allows to execute different blocks of code based on the evaluation of a condition. It includes if statement, if else statement, if else if statement, nested if statements, and switch statements. So let's know about embedded system. What is an embedded system? It is the combination of hardware and software, and the software is generally known as firmware, which is embedded into the system hardware. It is used to program a wide range of microcontrollers and microprocessors. It allows us to work with hardware devices like sensors and input-output devices. There are many types of embedded systems. There are network embedded systems, which are designed to interact with other devices or systems over a network, and mobile embedded system. They are specifically designed to operate within mobile devices such as smartphones, tablets, wearable gadgets, and automotive Infotainment systems. Real-time embedded systems are computing systems designed to respond to input stimuli or events within a specified time frame, which is known as a deadline. Standalone embedded systems are computing devices designed to operate independently without relying on external connections or interaction with other systems. So there are many components of an embedded system. Let's know it one by one. Components of an embedded systems includes central processing unit, which is a core component responsible for executing program instructions. It interprets and executes the code stored in memory, interacts with peripherals, and controls the overall operation of the system. Memory is used to store program code, data, and configuring settings. It includes both RAM and ROM. The another component is analog to digital converter, digital to analog converter, sensors, which measures physical quantities such as temperature, pressure, humidity, etc. Actuators, which convert electrical signals from the system into physical action or movement. Then human interface port, FPGA, software, and other auxiliary systems. The software tools used in our project are mainly MPLAB XIDE, PixMLab, and XE8 compiler. MPLAB XIDE is a free integrated toolset for the development of embedded applications on microchips, PIC and DSC PIC microcontrollers. It is called Integrated Development Environment because it provides a single integrated environment to develop code for embedded microcontrollers. PixMLab is a real-time emulator of development boards with integrated MPLABX debugger. PixMLab supports some Pixim microcontrollers and some AVR microcontrollers. PixMLab have integration with MPLAB, Arduino IDE for programming the boards and microcontrollers. XE8 compiler is a compiler developed by Microchip Technology specifically for their PC PIC microcontrollers. It's designed to optimize code for their microcontrollers, providing efficient use of resources like memory and power. This compiler offers user-friendly interface and intuitive command line options, making it easy for developers to compile their code. So let's know about PIC16F877A PIC Genius board. This microcontroller is widely used 8-bit microcontroller equipped with a powerful RISC CPU core operating at a maximum clock frequency of 20 MHz. Let's look into some of the functionalities of PIC1877A microcontroller. Their bus width is of 8 bits. Pin count it has of 40 pins and there are 33 pins for input and output. Program memory is of 14.3 kilobytes. CPU speed is of 5 million instructions per second. RAM size is of 368 bytes and EEPROM size is of 256 bytes. Let's know the architecture of PIC16F877A microcontroller board. It encompasses various components and peripherals integrated into the system. They are general purpose input-output pins, I2C. This component typically consists of real-time clock and EEPROM, LM35 temperature sensor, analog to digital converter, 7-segment display, RS232, character LCD, light emitting diode, buzzer, digital keyboard, and matrix keypad. Let us know some of the peripherals which are required to design and washing machine. This will be continued by my friend Abhishek.
Hello everyone, myself Abhishek and I will be explaining about the peripherals. The first one is the LED. A light emitting diode is a semiconductor device that emits lights when an electric current passes through it. LEDs are commonly used in various applications including indicators, displays and illumination and as components in electronic systems. LED may represent a specific state, providing users with visual feedback about the current status of the machine. A series of LEDs might illuminate sequentially to indicate the various stages of the wash, rinse, and spin cycles. And the second peripheral is the character liquid crystal display. It is a flat panel display technology that uses liquid crystals to modulate light and display images or text. LEDs operate by modulating light through crystals and controlled by the electrical signals. The LCD can be used to display relevant operational information to the user, such as the selected wash program, current cycle stage, remaining time, water level, and any error message or alerts. This provides users a real-time feedback about the status and the progress of the washing machine. Let's look into some of the functionalities and the pin configurations of the CLCD. It consists of 4 rows and each can print 16 characters. It can work on both 8-bit and 4-bit mode. D0 and D7 are the data transfer lines, and RS is set to 0 for instruction register, and RS is set to 1 for the data register, and it consists of enable pin or read and write pin. And the next peripheral is the tactile switch. Now, looking into the tactile switches, in microcontrollers, switches are often used as inputs to control the operation of the device or to interact with the users. When the button is pressed, the switches turn on, whereas when the button is released, the switches turn off. There are two types of operations, level triggering and edge triggering. In level triggering, the state of the switch is determined by the level or the voltages present at its terminals, whereas in edge triggering, in the state of the switch is determined by the transition or the change in voltage level at its terminals. Now let us know what is switch bonds in effect. It is also known as the contact bonds. When a switch is pressed or released, the electrical contacts inside the switch do not make or break contact instantaneously. Instead, it breaks the contact rapidly multiple times over a short period before settling into a stable state. This bouncing or the rapid oscillation of the contacts leads to the switch bouncing effect. Now let us look into the interrupts. Interrupts are nothing but the microcontrollers or hardware or software signals that temporarily suspend the normal program's execution to handle critical events or the external stimuli. When an interrupt occurs, the CPU suspends its execution of the current program and transfers the control to an interrupt service routine, which is also known as the handler, that will provide the requested service by the interrupt. When the ISR is completed, the original program resumes execution as if it is were not interrupted. There are two types of interrupt, hardware interrupt and software interrupt. Hardware interrupt are the signals generated by the external hardware peripherals or the internal components of the microcontroller. Further, these hardware interrupts are classified into two types, such as maskable interrupts and non-maskable interrupts. Software interrupts are known as the traps or exceptions or generated interrupts triggered by the software instructions rather than the external hardware events. Now let us look into the interrupt service routine. An interrupt service routine is a block of code that executes in response to an interrupt signal. ISRs are often organized in an interrupt vector table, a data structure that maps interrupt sources to their corresponding ISR addresses. A fan serves the primary function of circulating air to dissipate heat generated by the electronic components such as microcontrollers, processors, power supplies, and other integrated circuits. Looking into the buzzer's primary function is to generate the sound-based alerts or alarms to notify the users of specific events, conditions, or errors within the embedded systems. Now let us look into the timers. Timers and microcontrollers are the versatile hardware modules used for measuring the time intervals, generating the precise timing signals, and implementing the time critical operations. The PIC16F877A microcontroller has three independent timers known as ticks. Ticks refers to the smallest time increment that the timer can measure and to count the number of cycles. There are two types of tick, up tick and the down tick, where the up tick is used to count in ascending order, meanwhile the down tick is used to count in the descending order. And the another timer is the quantum. Quantum refers to the time taken by one tick, whereas the resolution is the width of the time register. Here, the scaling refers to the division of the timer's input clock frequency to reduce the effective tick duration and increase the timer's range or period. Now let us know what is watchdog timer. Watchdog timer is designed to monitor the operation of the microcontroller's firmware or software. If the firmware gets stuck in an infinite loop and it encounters a software bug, the watchdog timer resets the microcontroller to bring back it to known state and resume the normal operation. Now, the problem statement is to develop a washing machine interface and simulate it, which develops and allows the user to select different types of washing programs and water levels on pressing the digital keypads and selecting the particular operation by a long press. On the start of a machine, it should display the function running and the remaining time also. It should stop when the door is opened. Now, let's look into the functional requirements to design a washing machine. Here, we will be using a microcontroller PIC16F877E for the simulation, and the switch 5 is to turn on the washing machine, and the switch 6 is to stop the functioning of the washing machine. Switch 4 is used for the navigation to scroll down through the options available, and switch 1 for the door status, and CLCD for displaying the washing status, and the buzzer to indicate the door status and the completion of the program. Now, let us look into the first functional requirement, that is the power on screen. And the first requirement on the washing machine is the power on screen. Here the input is switch 5. When the switch 5 is pressed, the output has to be printed as powering on. And the next functional requirement is washing program screen. When the power is turned on and switches the washing program screen, washing program menu appears with a list of options such as daily, heavy, delicates, wise, and many more. Now, when the switch 4 is used to scroll down through these options, and selecting this particular option is through a long press of switch 4. Now let us look into the third functional requirement, that is the water level screen, which displays the water level menu with options such as auto, low, medium, high, max. And switch 4 is used to scroll down through this option, and a long press of switch 4 will be able to select a particular option. And the fourth functional requirement is the start screen. It asks the users to press the switch 5 to start the operation, and when the switch 5 is pressed, it displays the function selected and the time duration and switch to the function screen. Meanwhile, when the switch 6 is pressed, it goes back to the washing program screen. And the fifth functional requirement is the function screen, where it is used to display the function and the time left. It displays the functions such as wash, rinse, and spin, and a particular time is allocated to the function based on the washing program and the water level. When the switch 1 is pressed, it signifies that the door is open and the buzzer is turned on, and it has to display the door is open, please close. And the sixth functional requirement is that completion of the program. When the program gets completed, it has to print the program completed, remove clothes in the CLCD. Now, looking into the flowchart, upon resetting the board, the CLCD will display press key 5 to power on the washing machine. The user needs to press switch 5 to power on the washing machine. So, there should be conditional construct to keep on checking whether the switch is pressed or not. If the key is pressed, next the washing machine will be displayed on the CLCD. Otherwise, it will display the same previous statement until the switch is pressed. In washing machine program, there are multiple options to select. Upon selecting any other option, it switches to the water level option. After setting these two parameters, the washing process gets started. The function screen displays the time required to complete the process and function is performing at the present time. After the time, the CLCD displays the program completed and remove lots and comes out of the loop. Now, let's look into the code required to design a washing machine. This code for the simulation of the washing machine using a PIC16F877, a microcontroller. The code includes a header file main.h, which contains the definitions and the declarations necessary for the program, and the configuration bits are set using hash pragma config to config the watchdog timer as off. The global variables such as operation mode, wash time, rinse time, and spin time are declared to manage the operation of the washing machine. And the arrays are declared to store the washing machine programs and the water levels. The prototypes of functions used in the code are declared. This helps in informing the compiler about the functions before they are used. And the function init_config is initialized where various components of the washing machine such as CLCD module, digital keypad, timer, and fan modules are initialized. The peripheral interrupt enable and the global interrupt enable are set to enable the peripheral and global interrupts respectively. Looking into the main function, the main function is initialized using the init_config function. The initial messages are displayed on the CLCD to prompt the user to power on the washing machine. The program waits until the user presses the power on button, that is the switch 5 button. Once it is powered on, the main loop starts. The power on screen is displayed using a function power on screen, which displays a graphical representation of power on sequence on the CLCD. And the main loop continuously reads the input from the digital keypad and performs the action based on the current operation mode. And it displays the washing program display function with help of a function washing program display, which allows the switching of washing programs options using switch 4. And a function named water level display is used to display the available water levels on the CLCD, and the switching of water level options is done using the switch 4. And the function named set time for program is set, which sets the wash, rinse, and spin times based on the selected washing program and the water level. And a function named door status check is used to it checks the status of the washing machine door and alerts the user if the door is open and waits until it's closed to resume its function. And a function run program is used, which manages the execution of the selected washing program and updates the CLCD with the current program status and the remaining time, handles pausing the program if switch 6 is pressed. And it also alerts the user and resets the operation mode once the program is completed. Overall, this code provides the logic for a washing machine simulation. Now, let us look into the working of the washing machine simulation in PixSim Lab. This PixSim Lab includes CLCD to display the operations performed and the switches to control the operations of washing machine. We will be considering these switches as switch 1, switch 2, switch 3, switch 4, switch 5, switch 6 correspondingly. And it also includes a PIC16F8677A microcontroller and a reset button and a series of LEDs to indicate the various stages of operation, and the buzzer to indicate the door status and the completion of the program, and the fan which runs during the functioning of a washing machine. Initially, the LCD is set to 16 into 4 LCD and the clock is set to 20 MHz and the corresponding X file is loaded here. Now, when the program is loaded, initially it displays press key 5 to power on washing machine. When the switch 5 is pressed, it displays power on washing machine and switches washing program screen. And it displays the washing program menu. And by pressing switch 4, we will be able to scroll down through the options and select the particular options by a long press of switch 4. And by the long press of switch 4, we will be able to select a particular option, which then switches to the water level screen, and we will be using the switch 4 to navigate through the water level options, and this By using the same switch 4, by a long press of it, we'll be able to select the particular water level option, which leads to the press switch screen, and the user asks us to press switch 5 to start the operation. Once the switch 5 is pressed, it will display the program and the function it is running and the time it takes to complete the program. Meanwhile, the fan starts to run during the operation of the program, and when the switch 1 is pressed, which is used to indicate that the door is open, the buzzer starts to ring, and the buzzer starts to ring and it is displayed as door is open, please close. So a particular time is allocated for each operation such as wash, rinse and spin. So once when the program is completed, it displays program completed, please remove clothes. Meanwhile, when if the switch 6 is pressed, it leads to the washing program screen. When the switch 5 is pressed, it starts the continuation with the program. So now when the program is completed, it displays the program is completed, remove the clothes, and the buzzer also sounds. Hence the simulation works successfully as per the functional requirement. So we would like to conclude by quoting that the washing machine simulation using PixSim Lab served as an effective tool for learning and applying concepts in embedded system. It offered an hands-on experience that complemented theoretical knowledge and provided a foundation for further exploration in the field of automation and control systems. We would like to thank Emertxe Information Technologies for providing this opportunity. Thank you.